Alright, this is section 5.5, part 2. We are trying to find all the real zeros and then put that into factored form. So let's set this equal to 0. What I'm going to do is I'm going to try to factor this. Looks like I can break this down into 1 and 10, 5 and 2, and looks like that's it. None of which will give me back 2. This will give me 3 or 7, but it will not give me 2. This will give me 11 or 9, but it won't give me 2. So it looks like I'm going to have to use the quadratic formula here. So x is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a, where our a, b, and c from our polynomial is 1, 2, and 10. So this will be negative 2 plus or minus 2 squared minus 4 times 1 times 10 divided by 2 times 1. Okay, so that'll be negative 2 plus or minus, that will be 4 minus 40 divided by 2. So 2 minus plus or negative 2 plus or minus the square root of 4 minus 40, that's negative 36 over 2. Okay, I got negative inside a square root, so I'm going to take an I out. Okay, so that's going to be negative plus or minus. Square root of 36 is 6. So 6i over 2. If I can take a 2, well, we can break it up like this. That would be negative 1 plus or minus 3i. Okay, so there's our zeros. We've got 2 of them. We've got one that is negative 1 plus 3i, and we also got one that is negative 1 minus 3i. So there's our zeros, and these are non-real since I've got the I, that's imaginary. Okay, we're going to write this in factored form. Okay, so let's make a little room. Okay, so r of x is the same thing as x minus, okay, this whole thing, and then x minus this whole thing. So we've got negative 1 plus 3i, and we've got negative 1 minus 3i. Okay, so that's going to be x plus 1 minus 3i, x plus 1 plus 3i. Okay, so there's the factored form of r of x. Now let's go on to this one right here. So I'm going to set this equal to 0, x plus 4, x minus 8, 2x squared plus 7x plus 3. Okay, so we're going to divide these up. Okay, this one, x is equal to negative 4. X is equal to 8. Okay, and now we've got, by the way, over here, x was squared, so we should have 2 roots, and we did find those 2 roots. Here we have, here's an x raised to 1, here's an x raised to 1, here's an x raised to 2, so I have x times x squared. So if I add those up, 1 plus 1 plus 2 gives me 4. So my degree is 4. So I should have 4 different ones. So here's 1, 2. This one right here should give me 2. Okay, now what I'm going to do is I'm going to use the shortcut method to solve this. So this is going to be x squared plus 7x plus 6. I'm going to factor that. So that'll be x here, 6 and 1 both positive. Need to divide back what I took out. Okay, so we've got x plus a half and x plus, that's 3. Now I'm going to set each one of these equal to 0. So this is x is equal to -1/2, and this is x is equal to -3. Okay, so there's my other 2 zeros. So I have 1, 2, 3, 4 zeros, and I have a degree of 4. Okay, so there's all my zeros. Okay, let's look at this one. Find all the zeros. So 0 is equal to x plus 1x minus 6x minus 9x plus 11. So for each one of those, I'm going to set them equal to 0 because of the zero product property. So this was x equals -1, x equals 6, x equals 9, and x equals -11. So this one is x raised to 1, as well as this one, and this one. So x raised, or times itself 4 times. 1 plus 1 plus 1 plus, rewrite that, plus 1 plus 1 plus 1. So that's 4. And hey, I have 4 roots there, or zeros. Okay, let's look at this one. So 0 is equal to x minus 15, x squared plus 3x minus 4. Okay, so x minus 15 equals 0, and x squared plus 3x minus 4 equals 0. So this equals 15. Now I need to factor this one. It looks like I can factor a 4 and a 1. Make this a negative, make this a positive. -1 times 4 is -4. 4 minus 1 is a +3. Okay, that works. So set each one of these equal to 0. So x equals 1, x equals -4. Okay, this x is raised to 1. This x is x squared. So that would be 1 plus 2, or 3. And hey, I have 1, 2, 3 zeros. Alright, same thing, find all the zeros. So x plus 4, x minus 5, x squared plus 5x plus 6. So let's see, we've got x plus 4 equals 0, x minus 5 equals 0, x squared plus 5x plus 6 equals 0, x equals -4, x equals 5. I'm going to try to factor this, see if I can. X and x, 3 and 2. Okay, 2 times 3 is 6, 2 plus 3 is 5. Okay, that works. So x plus 2 equals 0, x plus 3 equals 0, so x equals -2, x equals -3. Okay, this x is raised to 1, this x is raised to 1, this x is raised to 2. So I have x 1 plus 1 plus 2, x raised to 4, and 1, 2, 3, 4 zeros there. Here, we're going to find an equation of degree 4, polynomial with a given zeros of -2, 9, 7, and 1, and we're going to assume that the leading coefficient is 1. When it says, hey, we're going to assume that the leading coefficient is 1, and actually it was back here, so I don't have to rewrite it. Let's talk about this right here. This is the coefficient, leading coefficient, A. They're talking about that is equal to 1. So you don't have a number like 5 and x minus 1, x minus 2, x plus 3, something like that. You don't have a number in front of it, so it's just 1. Okay, so f of x is equal to 1. That is our leading coefficient, A there. X, okay, I'm going to take this one. That's going to be plus 2. Take this one. This is going to be x minus 9. Take this one, x minus 7. And this one, x minus 1. So to rewrite it, all I really need to do is take away that 1 because it's assumed. And then there's my equation right there. Let's look at this one. Find an equation of degree 2 polynomial with the given zeros. 4 and negative 6, and we're going to assume the leading coefficient is 1. So f of x, put a 1 here, x minus 4, x plus 6. Okay, take away that 1, don't need it. And then there's our equation. Now you could extend it out. You could take this x times this x and times this 6. Negative 4 times this x and times this 6 as well. So that would give you x squared plus 6x minus 4x minus 24. So that would be x squared plus 2x minus 24. Either one, that's the same thing here. These two are the same thing. One's just factored and the other one is just not factored. You could do the same thing with this one as well. It would take a little bit, but you could take x times this x and times this negative 9, and then times 2 times x and times negative 9. And then you can take whatever that is and multiply it times this, and take whatever that is and multiply it times this times this. Write a factored form of the polynomial function with real coefficients, a leading coefficient of 1, and zeros of negative 5, 8, 2, and 3. Okay, so let's do that. So we have a lead coefficient of 1. Okay, and so we're going to have x plus 5, x minus 8, x minus 2, x minus 3. And that's it. All I do is look at those and I change the signs and have an x in front of those. And that's it.